Imagine if you stopped eating right now. Not forever, not for a week, just for a day. Most people believe they already know what would happen. Energy would begin falling. Hunger would become unbearable. The brain would struggle. The body would start running out of fuel. After all, food is what keeps us alive. So removing food should immediately make the body weaker, right? But something strange happens when scientists actually study the biology, because the human body does not react to the absence of food the way most people imagine. In many cases, the exact opposite occurs. The body becomes more efficient. Certain repair systems become more active. Stored energy suddenly becomes accessible. The brain changes the fuel it runs on. And deep inside your cells, ancient biological programs begin waking up that remain largely dormant while food is constantly available, which raises an uncomfortable question. If food is necessary for survival, why did evolution build so many powerful systems that only activate when food disappears? To understand that mystery, you have to forget almost everything modern life has taught you about hunger, because hunger feels like an emergency, but biologically, it isn't. Think about the last time you skipped a meal. Maybe you were busy. Maybe you forgot. Maybe you were traveling. At some point, a signal appeared, a sensation in the stomach, a growing awareness of food, an urge to eat. Most people interpret that sensation as proof that the body is running out of fuel. But that's not actually what is happening, because hunger is not primarily a measurement of energy. It's a prediction generated by the brain based on patterns. And once you understand that, the entire story of fasting begins to change. The body, it turns out, was never designed for constant feeding. It was designed for cycles, periods of abundance and periods of absence. For most of human history, breakfast was not guaranteed. Lunch was not guaranteed. Sometimes dinner wasn't guaranteed either. Food arrived unpredictably, and any organism that became weak, confused, or incapable during those gaps would have disappeared from the evolutionary record. The organisms that survived were different. They became sharper when food became scarce, not weaker, more focused, not slower, more motivated, not less, because finding food required energy. Finding food required intelligence. Finding food required survival systems that activated precisely when eating stopped, which means something remarkable. The fasting state is not a malfunction. It is a biological mode, a completely different operating system your body has been carrying for millions of years. And most people rarely activate it, because the modern world never stops feeding them. The moment hunger appears, food follows. The moment energy dips, a snack arrives. The moment the body begins transitioning toward its secondary fuel system, the process gets interrupted. Again, and again, and again, which means millions of people spend their entire lives using only half of the metabolic machinery evolution gave them. The question is, what happens when the other half finally turns on? Because that's where the biology becomes extraordinary. Your body is carrying two completely different energy systems. Most people spend their entire lives using only one of them. The first is familiar. It runs on glucose. Every time you eat carbohydrates, your digestive system breaks them down into simple sugars that enter the bloodstream. Those sugars become immediate fuel. Fast, convenient, easy to access. It's the biological equivalent of cash in your wallet. Always available, always ready to spend. But there's a problem. The supply is surprisingly small. The average adult stores only enough readily available glucose and glycogen to power roughly a day of normal activity. After that, the reserve begins running low. And this is where most people imagine the story ends. No food means no fuel. No fuel means less energy. Less energy means the body starts shutting down. But evolution had a different plan, because hidden beneath that small glucose reserve sits something far larger, a second fuel system, one specifically designed for periods when food is unavailable. Fat. For decades, body fat has been treated almost like a mistake, something the body accidentally accumulates, something unwanted, something to get rid of. But biologically, body fat is one of the greatest survival technologies ever created. It's stored energy, compressed, protected, waiting. Even relatively lean people carry tens of thousands of calories inside their fat cells. Enough energy to keep the body functioning for days or even weeks. The question isn't whether the energy exists. The question is why the body doesn't use it immediately. The answer comes down to a single hormone, insulin. Every time you eat, insulin rises. Its primary job is simple: move nutrients out of the bloodstream and into storage. But insulin has a second job that is rarely discussed. It acts like a lock. As long as insulin remains elevated, your fat stores stay largely inaccessible. The fuel is there, but the door is closed. Imagine having a giant backup generator sitting beside your house, fully fueled, perfectly functional, but connected to a switch that prevents it from turning on. That's essentially what insulin does. When food is abundant, the body prefers incoming fuel. Why use stored energy when fresh energy keeps arriving? The system makes perfect sense until food becomes constant, because every meal raises insulin. Every snack raises insulin. Every sugary drink raises insulin. And every rise delays the moment when the body can finally access the reserve. It spent millions of years evolving. The result is something strange. Many people are surrounded by stored energy, yet rarely enter the biological state required to use it. And when that state finally arrives, something remarkable begins happening. The body doesn't panic. It adapts. Insulin falls. Another hormone, called glucagon, begins rising. And deep inside the liver, an ancient metabolic switch quietly flips. A switch that changes not only how the body burns fuel, but how the brain itself is powered. And that is where fasting stops being about food and starts becoming a story about human evolution. The moment that switch flips, your body enters a state that most people rarely experience. Not because it's dangerous, not because it's unnatural, but because modern life almost never gives it the opportunity. For thousands of generations, periods without food were built into everyday existence. Humans hunted, gathered, migrated, waited. Sometimes food appeared quickly, sometimes it didn't. The body evolved under those conditions, which means the fasting state isn't an emergency mode. It's a normal biological program, a program your body expects to run. And one of the first things that happens when it activates is something remarkable. The liver begins manufacturing a completely new fuel, not from food, from fat. These molecules are called ketones. And despite what many people believe, ketones are not a backup system. They are not what the body reluctantly produces when everything else has failed. In many ways, they are a premium fuel. To understand why, imagine a city that suddenly changes its power source. The lights still work. The buildings still function. But the energy feeding them becomes cleaner and more efficient. Something similar happens inside the brain. Most people think the brain can only run on glucose. That's not true. When fasting continues long enough, the liver converts fatty acids into ketone bodies, which travel through the bloodstream and cross directly into the brain. Once there, neurons begin using them as fuel. And what scientists discovered surprised them. The brain doesn't merely tolerate ketones. Under many conditions, it performs exceptionally well on them. Research has repeatedly shown improvements in mental clarity, attention, and cognitive performance during periods of mild fasting, which creates an evolutionary mystery. Why would the brain become sharper when food disappears? Shouldn't the opposite happen? At first glance, that seems logical. No food should mean less energy. Less energy should mean poorer performance. But evolution doesn't care about logic. It cares about survival. Imagine an early human who becomes tired, distracted, and mentally slow whenever food becomes scarce. That individual would struggle to hunt, struggle to navigate, struggle to solve problems, and ultimately struggle to survive. Now imagine another individual, someone whose brain becomes more alert when food disappears, whose attention narrows, whose senses become sharper, whose focus improves. That person has a much better chance of finding the next meal. Over thousands of generations, natural selection strongly favored the second strategy. The result is a nervous system that often becomes more focused during moderate fasting, not despite evolution. Because of it, scientists sometimes call this effect the hunter's advantage, the biological tendency for mental performance to remain stable or even improve during short periods without food. This isn't motivation. It isn't mindset. It's chemistry. As ketones rise, the brain begins operating in a slightly different metabolic environment. Neurons produce energy more efficiently, certain signaling pathways become more active, and levels of a molecule called BDNF begin increasing. Brain-derived neurotrophic factor. Think of BDNF as fertilizer for the brain. It supports learning, memory, adaptation, and the growth of new neural connections. In animal studies, fasting consistently increases its production.